And welcome to the Introducing Giza Advanced Performance and Analytics for Streaming Imagery webinar. And we're going to start off the presentation right now, actually. We're just going to get right into it today. We have a great presentation lined up for you. And if you could just head to the next page, we'll get it kicked off. And I myself will make some introductions right now to our speakers today. First off, we have David Breeding. He's our principal. He's a principal at the company, at Applied Geographics, or AppGeo. And by the way, just a little bit more about Applied Geographics before we do make the introduction. We've been in the geospatial business for over 25 years. And Giza is one of our flagship products. What it does is it streams and analyzes. It allows you to report on and really give a new level of performance to your imagery program. So we're going to dive into that today. And so, David, are you there on the call right now?
Yes, sir. Yes, I am.
Excellent. And also, our next presenter on the call today will be Aaron Doucette. Aaron is a sales engineer here at AppGeo. And Aaron, are you on the call as well today?
I am. Thank you.
Perfect, perfect. So on the next slide, I'm going to kick it over to Aaron, and he's going to take over the agenda. But I just want to real quick remind everybody, if you did just join us, that we will be fielding questions for the duration of this webinar, going over them at the end of the session. Thanks.
Great. Well, if we have our audience here, I think we can get started. So I wanted to first walk through our agenda, tell you a little bit about AppGeo. Many of you may have heard of us, but for those of you who don't, give you a little background there. And today we're going to be looking at the ongoing transition to cloud-hosted imagery and what that can mean for your organization or for your state. And going a little more in depth in that topic into some of the cost savings, how moving to an imagery program such as this can really reduce your costs and improve the return on investment you're making into your program, and also some of the speed and scalability that comes with the cloud transition. So looking at the advantages when it comes to ease of use, ease of access, and of course, performance. Just taking a look at who we have on the webinar today, a pretty great audience from all around the country. So we thank you for making time out of your busy schedules to join us today. Just so a little bit about AppGeo. We are based in Boston, but have staff located around the country as well. And we've been delivering GIS and geospatial location intelligence solutions for over 28 years. So about as long as aerial imagery has been a thing in the digital world. And even before, we've been working with it. And our technical knowledge and experience goes beyond just selling imagery or selling a product. We really work closely with our clients to understand their needs, get them the right tools, and help them answer the questions that they're really looking at. So we encourage you to follow up and learn a little bit more about some of our key projects afterwards, and trust that you're in good hands when working with AppGeo. So to get right into it, I want to start off by thinking about how the imagery world is changing, and specifically how your organization is using imagery differently now than maybe you did 5 or 10 years ago. As sensors and data become finer and more advanced with every coming year, the first thought we've had is just about how much more you can do with imagery. Most of the time when people are using imagery, they're trying to do something with it, not just look at it for how cool it is. Maybe I actually do that, but I'm a bit of an odd example. And, suddenly activities that required a crew in the field can be done from the desktop when you have the level of accuracy and the level of image quality that we are now bringing in. And these new forms of analysis let us observe change maybe year over year. But all these great possibilities put increased strain on our current imagery infrastructure. So to look at that in more detail, we're seeing both larger and increasing numbers of individual data sets as we add more bands to our collection technology, or increased specificity of data needs, like having both leaf on and leaf off data sets. But we also have more users as more departments start seeing the value imagery can add to their workflow. So with more users comes an increase in the number of platforms users want to access your data through. Different departments are experienced in different software or different technologies, each meeting their own unique demands. And lastly, all of this comes at a cost of increased bandwidth on top of the existing demands to your IT infrastructure. And we're seeing this change happen in real time, more and more than just across the public sector, but in the private sector too, as maybe they're going from one GIS guy to now a whole department or a whole number of users who want to have this information, or maybe it's a vital part of their workflow. So as an imagery reseller on top of the services we provide, we have a really good insight into what markets around the country are using imagery and in what ways. And these are just a few of the areas we've seen growth in the consumption of imagery, the need for imagery in the past few years, within agriculture and environment, insurance providers, and property and real estate, as well as traditional users like engineering and departments of transportation. Just more and more projects where imagery is at the core of what they're doing. Furthermore, we're seeing more industry users rely on imagery, along with the growth in American manufacturing, especially within energy and renewables, and also in the public safety sector, an area that AppGeo has been heavily involved in and committed to supporting through our project work. All of these different users historically may have not had an imagery program, but now it's becoming more and more vital to their day-to-day operations. So taking a look back in time at all these potential imagery workflows, let's look at where we came from when it comes to imagery. Historically, everyone may have had their own copy of the imagery data sitting on their hard drive. Makes sense, right? And all of the processing and analysis took place locally on that specific machine. Now, this can work great if you're a power user, but it puts a lot of demand on that one machine to be correctly equipped, have enough storage, and have the right software packages installed, which can be costly to license. Now, as teams grew and the need for collaboration increased, network approaches kind of took precedence. And that's where we have, increased shareability, but it's putting all that burden, all that traffic on your local network, and still requires having specialized software for each end user to read in the data and work within, your mapping application. Additionally, this leaves you on the hook for the cost of backups, security, and a whole lot of hard drives to store all the information. Now, over the last few years, we've been seeing organizations generally move to a hosted solution, although historically this has been stood up on organizations' own infrastructure, hosting a server locally that is doing all the heavy lifting. But what this has done is opened up the whole world of WMS and WMTS, some acronyms you'll hear a couple more times during this presentation, technology, and really brought on the widespread adoption of those type of hosted access to data. So looking at a few challenges here that we inherently have within this paradigm. The large file sizes inherent to imagery require having adequate storage and high-end machines that can handle that imagery. This is costly, especially when now we have more and more users that want to get at the data. Intensive post-processing, need to mosaic downloaded files if that hasn't been done for you. And again, all the specific software required, some of the speed issues when it comes to, a network that's being shared for a whole lot of different purposes, not just looking at imagery all day. And again, having all of these on-premises servers have their own associated costs, staff to keep them running up and up to date, and of course, secure. So in review, here's a quick timeline that kind of shows where we feel the industry is moving, which is to a cloud-based approach. And this is in line with what we've seen across IT infrastructure as a whole. Outside of the imagery world, what is the rest of the world doing when it comes to their technology? And as teams become more remote, that's a pretty big deal right now, as our company is working remotely, as many of you may be at a work from home situation, but also more collaborative and more flexible to meet changing demands on a day-to-day basis. Can you imagine a world where YouTube simply offered a bunch of download links where you would have to download the video ahead of time and keep an archive of what you want to watch, and then maybe have a certain video player to watch it? That sounds crazy, but that's kind of where imagery was not that long ago, to whereas now we can get what we want when we want it. And this is really where the cloud comes in. So the tech giants of the world, the Googles, the Amazon, the Microsoft, Oracle, and so on, they have been competing neck and neck to see who can get more innovative in this space, because it is really the next big thing when it comes to infrastructure in the IT world. So you have a lot of options at your disposal, and they come with some pretty significant advantages. One that I think gets overlooked frequently is security. Cloud providers are investing in the best security out there, with redundancy and protection built in from the start. And as we've heard stories of ransomware and malware, especially now turning their sights on the public sector, this is a really big deal. And you have really valuable data, and the cost of not being able to access it is huge. And the cloud can solve that problem. The next area we've seen a huge advantage come from is in the cost perspective. Compared to this on-premises storage, this cloud storage is becoming increasingly more affordable, with more choices available in this area as well. And we've been working with the same technology to host some of our most critical applications that AppGeo's developed, and have had some really strong results even in the aftermath of disasters like Hurricane Harvey. Our tools that are supporting organizations have stayed online through those demands. And the part that will lead to a lot fewer headaches for you is the scalability and speed which we now have available, which we'll focus on in a bit more detail here in just a minute. So what is behind all of these possibilities? And it really comes down to tiling technology. So advances in tiling have been at the core of this transition to the cloud. Image tiling and raster pyramids are actually nothing new when it comes to raster imagery, aerial imagery in GIS. These approaches have been built into desktop GIS applications for some time. They allow your computer to more speedily load the imagery rather than, have to bring multiple gigabytes of data into RAM. But the ability to pre-tile and render this data ahead of time for mass distribution on the web has changed the game completely. So for many of you, you might understand how this works on a technological level already, but essentially we're just breaking down a very large, very detailed image, which could be many terabytes in size, into more manageable bite-sized chunks, each one under a megabyte typically, which can then be downloaded rapidly and simultaneously over the web. And advancements in browser technology and some of the delivery technology on the web side have actually increased the ability for this to work really well. And this is technology that's being developed kind of in tandem for, you go onto a news website, you have 3 videos and 15 pictures all loading up at the same time. How is that achieved without your browser slowing to a halt? We're harnessing some of that same technology here when it comes to imagery. And that's where I'd like to bring up Giza, the product that AppGeo developed to take fullest advantage of all this new technological possibilities. The name Giza is in reference to the pyramids in Egypt, looking at tile pyramids, which you can see on the right here. We have successive levels, often called zoom levels, each containing more and more detail than the one above. And we built Giza out over the past 5 years, and so far it's supported 7 statewide implementations, as well as a number of county level and also private industry applications and users. And the key thing I want you to take away today, in addition to some of the other things you're about to see, is that Giza is not just a serving appliance, but a management engine and some of the powers that come with that. So we'll get into each one of these points in a little more depth throughout the presentation, but I wanted to share some of the key design principles behind Giza that make it unique. between having broad platform support, industry-leading performance and speed, reduction in cost, having access to all of the usage and the provisioning of that usage, and all of this coming together to be able to improve your imagery return on investment, because it really is an investment that you're making. So for many of you in the audience, at least at some point in your career, you've probably spent a lot of time looking at a window somewhat like this, myself included. And we believe Giza creates one of the easiest and most efficient ways to work with your imagery in your GIS applications, doing that through the WMS and WMTS compatibility. And this is especially true for base mapping purposes. You want to be spending your time in GIS, working with your data on top of the map, not waiting for the background to load. And in so many cases, you can get bogged down by, all right, my vector data, but the data that I'm editing, that's performing fine. But every time I move the map, I have to wait 10 seconds to get the new image to load, and that adds up over time, as we'll see. But again, great compatibility with all of the major GIS as well as CAD applications using these OGC compliance standards that are becoming more and more a default for so many software platforms. Going a bit beyond that, the other exciting thing about moving to a cloud-based solution is in many cases, we don't need GIS software at all. In a lot of ways, this is where the industry as a whole is heading for many applications, as mobile apps and putting data into people's personal mobile devices is becoming the norm. Having web-based portals and applications is now mission critical. And having your imagery as the backbone of these applications can unlock a whole lot more control than you would have with, say, a default base map that are available at the consumer level. And that's why we've made sure Giza can work well with the leading APIs that we support, largely Google Maps platform, but also Cardo and Mapbox can all integrate with Giza. So, enough talking. Let's look at how Giza actually works in action and how quickly it can load some of our high-resolution data from Utah, as we've partnered with Hexagon, an imagery provider. So this is some 15-centimeter data that we've been working with the state of Utah on. And I just want you to see in this live recorded video how quickly it loads as I go from one half of the state to the other, essentially. You can kind of see the pyramiding in action as we get down to the next zoom level. The imagery becomes clearer and suddenly kind of snaps into view without much of a delay. And at this point, I'd like to introduce David Breeding, who's going to speak a bit more to the performance and speed components of Giza.
Thanks, Aaron. Yeah, it looks like magic, and all users kind of really want it to be at the end of the day. They want to be focused on the work they're doing and just have the context required. But if we just go to the next slide, it's really not magic. And so I want to talk a little bit about how is this actually happening. And when you think about it, you have, whether it's an application or your desktop GIS, whatever you're using, I need tiles. And you would think, I want to minimize the amount of steps, that I'm going to take before the tiles get back, before that response is delivered. But in our case, and when we think about tiling and we think about how people need their spatial information, there's actually a lot of this spatial nature of this demand. I'm working in a particular location, frequently, oftentimes returning to it, kind of moving around in a localized area. It actually makes sense to kind of have a few more gating kind of logic steps or caching steps to make sure you have the fastest performance possible. So just looking at this kind of diagram quickly, when we think about applications that are running in the web, which Giza's often supporting, we want to make sure that we leverage that web technology to make sure those tiles are able to be stored efficiently in the browser cache, and so that whenever you pass through a zoom level or pass through an area, you go there first. It's like check quickly to make sure that it's not in the image cache. If it is, pass it back. The other really interesting thing we did when we consider, this appliance being leveraged by a variety of users that need access to the same data, is, well, where is everyone collectively kind of doing the work, and can we leverage that work and that kind of access trend, or where they're, if they're all working collaboratively in an area, what if we cached where everyone's working the most in this kind of Giza cache that we've kind of architected in our technology, and check their second. So if I'm a part of the team going to an area where my friend Aaron's been working for the past few days, and I want to check out his work, I don't want to have to go to the original store. What if I go to this cache? And this mechanism allows that tile to be delivered extremely fast. And so, but finally, the last step is to go to that source tile pyramid repository that we pre-cache. We like to pre-cache all of that imagery down and have all of these pyramids ready to go, so that we can get the best responses possible. But in short, this is how it works. This is where, it's this logic, these caching steps, the technologies that we've put together to make sure that imagery is you're never waiting on it. Next slide. But at some point, it's like, well, is this actually creating value? And while we were doing this architecture and kind of adding this complexity, we wanted to ask ourselves a little bit about, like, how fast do people actually need, imagery or access to this information in the web or in their work? And, people have been studying this for a number of years. And really one notable kind of thought process we had was just about that cognitive focus, or when we were reading these resources, when you have to wait more than a second is about the time at which your brain starts to kind of process, I'm waiting for something. I don't have what I need. I can't continue whatever that thought was, whatever analysis I was doing in my head. So we took that as the line in the sand when we were kind of developing, and then raced to go faster, but always keeping in the back of our head, like, how fast do we really need to go? And so to really not break the flow, these same studies that have been done, I think the original study was back in the 60s, but it's been kind of done. There's Nielsen and a variety of other, this is a meta study here at the bottom. But, if you can stay below 100 milliseconds, there's really no cognitive kind of delay going on. You stay focused, you're not reorienting to what's going on behind the scenes, and you can just do your work. So that was where we were. This was kind of the bounding logic behind kind of where we were going, what we were trying to shoot for, to really make sure people could be productive and that users were satisfied. Next slide. So, but we needed to go further. We wanted to put some numbers to this. Like, how do we fall, in that technology landscape? As Aaron already kind of had in our timeline slide, image serving appliances have been out there serving imagery via WMS, via WMTS, providing users with data. So, fortunately, Esri has a very common way of identifying their servers out there in the world. And so we did some work to go out there and organize from a variety of different states, of a variety of different kind of sizes. And we're pretty familiar with a lot of people out there, and just started to aggregate, do some statistical quantile definition of how fast these tiled images, as well as WMS kind of dynamic services, were delivering all of the tiles in a single response. I think that's the most important kind of piece of this. Is we talked about parallelization, where you have all these individual tiles being returned and kind of or requested and then returned. We really wanted to look at a number for what was the total time for all of the tiles in our view to be returned. So that's really these numbers falling into these respective quartiles. Given faster is better, that lower quartile being those fastest responses. The fastest it took on average for those kind of responses to come in for these three different segments that we've kind of differentiated. Looking at those specifically, we have Giza and its responses, and that dotted line being that 1 second response time that we were trying to shoot to kind of stay under. We've looked at a whole variety of WMTS services from, I think it was about 10 different organizations at varying sizes, and we picked one that was in the middle. There were some that were slower, there were some that were faster, but this was kind of, it fell in the middle. And so we just selected it rather than averaging it, giving a representative kind of example of what you might expect. And so some of those responses, or a large majority of those responses, kind of taking more than a second. And then finally, WMS being potentially really slow and potentially frustrating for users that really need that responsive kind of access. There's obvious benefits to WMS, data feeds. So again, we're thinking about that speed of access and maybe not some of the more processing you can do with WMS. To the next slide. So, but there are fast solutions out there, and we wanted to look at the fastest that we were finding out there. And honestly, like, there's some pretty good tech out there that does a pretty good job, that keeps maybe not the middle quartile or the median, or they satisfy the median, right, staying below that second, but there's still some wait times that were a little longer than we were trying to shoot for. So this is just to say, there's lots of technology out there, but we see Giza in our kind of work as being one of the fastest solutions that are out there if that performance is really important. The next slide. And so when we think about time and what that means, what are we saving? If we think about the median performance, actually, if you can go back 2 slides just to make this point, Aaron. If we look at the median or the middle quartile for that WMTS service, what really starts to matter is that time above 1 second, right? So if we look at all of the requests and we take that speed, that's that delay, and we subtract the difference between the median, the middle quartile for Giza, what's that difference? And if we were to add up, go to the next. If we were to add up all of that, delay time, that ideal time, like that wasn't being satisfied for the millions of requests that we see Giza responding to. These are actual monthly response request numbers for one of our largest being the 27 million kind of state customer with Texas, and then Tennessee being another customer, falling in around 1.8 million requests monthly. If you add up all of those, that additional time, we start seeing a significant amount of days of time being saved. Again, these have hundreds of users that are all making requests against a server. So this is just one way that we just wanted to add it up and kind of take a look and think about what we could be saving or what type of efficiencies could be gained when we think about optimizing for speed. And at this point, I'll turn it back over to Aaron to talk about a few more of the unique and compelling features that that Giza has.
Thanks so much, David. And I'll remind people, if you have questions, especially on any of those technical tidbits, feel free to ask them. And at the end, we'll have an in-depth Q&A where we'll get to all of those. So I wanted to share an example of where I've seen Giza add a lot of value in terms of a specific use case. Many states have been collecting imagery for years or even decades, but each of these data sets adds more and more information to host and distribute and account for the operability. And we've seen communities get more and more involved with doing change detection and time series analysis, like looking at their urban forest growth over a number of years or environmental assets over time, things that don't necessarily change that much from year to year. But if you look at a 10-year span, you can really start to answer some interesting questions. And with Giza, we can make all of this imagery available while keeping the costs down, which is pretty remarkable. I will give you an example here. In our home state of Massachusetts, they have imagery from the 1990s, the 2000s, and the 2010s, all that have a different snapshot in time. And bringing those into one application, for example, we can start to see some really cool things. And Giza is one way to do that rather effectively from a cost perspective, but also, having the ability to toggle on layers and have all this data at your fingertips within one analysis. Going a little more into what makes Giza special beyond just the storage alone. We here at AppGeo have a whole team dedicated to working with cloud technology to its fullest extent. And as such, a lot of Giza's functionality lies within some of the cloud computing that we can tether into on the back end. And this helps support the analytics and management piece beyond just the speed and storage. So looking at the Google Cloud stack that we work within, we have the storage, but also compute engine and BigQuery, which in our case allow us to do very detailed summary statistics on each individual tile and tabulating this up over time and rolling it up by, say, user or group or time or permission, and track all this usage over a number of years. And we'll look at how that actually looks in just a second here. So looking at the analytics piece, organizations allocate a great number of resources into creating these data sets, commissioning a flyover, purchasing imagery from a vendor. But as of now, they often have pretty much no visibility into who is using them or for what purpose or how they're being used or what's being downloaded. And with Giza, we can put numbers behind all of these elements. And this helps establish a clearer picture into your imagery use and opens up a whole handful of possibilities that were previously unavailable that come along with that, such as establish prioritization for new flights, make better decisions around storage, and also introduce new insights into maybe how the public at large is utilizing your data. So a key example of this is in our heat map functionality. With Giza's heat mapping, at each zoom level, we can see in the form of a heat map the exact number of requests a given tile has had to be downloaded. And this becomes finer and finer as we zoom in. So here's an example from our Utah data. And we can see Salt Lake City on the further out view. But surprisingly, we also see a large amount of usage in this more rural part of the state. And, that could have gone completely under the radar before. But it turns out we have, a highway construction project here on this major interstate linking with the state highway. And that turned out to be one of the most in-demand areas for imagery in that particular year out of anywhere in all of Utah, where, off the cuff, you might not have thought so. Additionally, we've seen some other pretty cool examples. David, did you have any to share from your experience?
Yeah, no, happy to jump in there. When we first built this, we knew there was value, but we really were relying upon, kind of our partners to expose some of that. And one really interesting example, that came out that we couldn't have predicted. We were working in Texas, and the Customs and Border Protection groups were leveraging those assets. And what we started to notice when we again filtered on user, which is kind of the critical thing, we'll talk about user control in a minute, but it really allowed for teams to kind of where are they working, because a part of their workflow was kind of investigating imagery, and you could start to see these trends of overlaps or areas of focus that weren't really obvious, in their other data from response data perspective. So they started being able to derive, from this Giza kind of heat mapping, where there were potential inefficiencies as far as response and like a surveillance was concerned, and where the most activity was actually happening from a kind of crossing the border perspective. So, and then also from a kind of research perspective, universities leveraging, I think again in Texas, where those research projects were going on in some of the more rural parts of the state, and quantifying, that effort and where it was taking place, and being able to show to decision makers, look at how this asset is kind of supporting research and getting kind of cited in papers, and allowing kind of for your novel research to take place. Again, tells a good story and also helps people make good decisions. So that's just some example of how the heat mapping specifically has played a role.
Thanks so much, David. So looking at those decisions, the heat map can show us where imagery is being used, but there's actually quite a lot of value, believe it or not, in where it's not being used. And I'll explain that here. So by incorporating this knowledge around real life usage, we can take advantage of the fact that cloud storage is not sold as a one size fits all package. There are actually numerous pricing tiers to take advantage of, from the highest speed and performance to something known as cold line, which keeps your data accessible and safe, but at a real fraction of the cost when you look at that per gigabyte cost. And when it comes to image especially, demand is not equal across every tile. And we found through our work that at the higher zoom levels, when you're more zoomed in, the tiles that take up the most storage, often these can go entire years without actually being needed to be downloaded or used, just because, maybe they're in an area where there's no analysis going on, especially in states with more rural areas. And by reconfiguring your storage allocation based on actual demands and being able to scale those up or down as needed, states and organizations can realize huge saving potential. So you can kind of see the scale here ranges from the red, yellow, green, and then blue, each getting a pricing discount. So here's an example of how we helped one state do just that in Texas, where with the Giza, they have imagery going back a number of years, all the way, in this case, to 2011, a full data set for the whole state, in some cases, for every single one of those years. By utilizing this method of reconfiguring their storage buckets, they were able to save nearly $70,000 annually just in storage alone. You can see the numbers there. So much of that total 267 terabytes was in tiles that were most efficiently stored in cold line. And, say a project came up and they're going to be accessed more frequently. Well, moving them to a more speedy bucket is very easy as well. But this at least gives you some hard numbers behind making that decision. As David had mentioned, I'll wrap up by touching on a couple more features that are at the core of Giza and really well liked by our customers. The ability to create and manage individual users is pretty critical, not only from the perspective of having login and access control, but for the monitoring of who is using what, provisioning individuals or teams. From my perspective, this has two big implications. One, for states who might be working with different contractors and firms who they want to provision to work on a certain project, you can easily give them access to your imagery assets with as little effort as sending an email. You don't have to load up a hard drive and mail it over to them anymore. But secondly, we've actually seen some states move to a model where internally they're incorporating a cost sharing model between state organizations and departments, where different departments within that state can each pay their share according to usage. So, for example, in a state where we have DOT and the environmental protection and law enforcement all using Giza, you might be able to allocate different cost share within your organization, help pay for your imagery program that way according to usage, which in our opinion is a really fascinating way to break it down rather than having all of that cost burden fall on your geospatial group. And lastly, last but not least, I wanted to bring up our download functionality. This has been very important to a number of users, so I wanted to make sure you're all aware of it. Within a particular view on Giza, we're able to provision these focused downloads where the raw JP2 files or GeoTIFF, the source imagery that you started with, is sitting in an accessible format. And we're able to summarize what's on the screen at a given time and send the download links to the user in a pretty streamlined fashion. We also, as a service through what we call our Spatial IQ packages, have access for bulk downloads for states who might need to be getting at larger areas for a particular project. That's something that we can offer at a service-based level. So again, just more ways to get at your data, more speed and more flexibility with a lot more accountability as to how it's being used by who and for what. So to finish up here, we've seen a lot of cool visuals on the screen, but a lot of folks are looking at where do I get new content? And I'll add a shameless plug. We put together a imagery provider comparison guide that goes through all of the major providers for aerial imagery and now some satellite providers as well, really breaking down their product offerings and seeing what's right for your organization. AppGeo, we are a hexagon imagery partner, so a lot of the demo imagery you've seen here today is coming through their program. And Giza is also compatible with just all of the other imagery providers you may be currently working with. So we encourage you to check out that guide and some of our information around there if you have more questions about imagery itself and getting the freshest content or the most high resolution content that's out there in the marketplace. And with that, I'd like to take it to the Q&A. We really thank you for being a part of this presentation and look forward to answering some questions here.
All right, so once again, the questions box is located on the GoToWebinar tool. So if you just pop out the little arrow, you can ask questions and we will stay until these are all finished. So you actually did just finish up with one of these questions. So does it matter who my aerial imagery provider is or who my imagery provider is?
Sure. And, you actually make a good point there that I didn't touch on so much in the webinar, but tiling imagery and raster imagery is actually not just limited to aerial ortho photos, and that we've seen, for example, scanned maps or like scanned USGS topos being able to be hosted through Giza, or historical imagery that has now been geo-referenced. Essentially, anything that you would be overlaying on top of a traditional GIS environment, Giza can host. In terms of the providers that are out there, all have different characteristics and are ideal for different tasks. But Giza is very platform agnostic when it comes to the source imagery, assuming that it's in a format that can be tiled and has, the geographic precision needed to overlay it onto a map accurately. So hopefully that answers your question, but I'd be happy to follow up in more detail if that sprung any new ideas.
Excellent. And so we did have a number of questions about getting the recording for this webinar. And yes, absolutely, we'll be getting this webinar recording out to each and every one of you. In addition, if you go to appgeo.com/Giza, you can learn more information. And of course, if you go to appgeo.com, you can submit our contact form and we'll be happy to reach out to you. So we do have more questions. And again, we will stay for all of these questions. Do you deal with contracting new acquisition?
So
Aaron, do you want to take?
Sure, I'll take a stab at that. We have worked closely with our imagery provider in terms of setting priorities for acquisition. We're not a collector ourselves. We're not out there flying the planes, but we work closely with the folks to do. And when we have interest from a state, as a partner, we have some of that potential to guide the conversation and in some cases, establish precedent for those acquisitions that may have been on a longer schedule. Again, that's kind of a more in-depth question, so we'd love to get in further talks with you on that one, but that's been a little bit of the history I've seen when it comes to new acquisition. David, do you have anything to add on that front?
Yeah, just to jump in, from a new acquisition, custom collect kind of is always an option. We've actually have a history of supporting, local municipalities and other kind of local governments and kind of organizing, procuring, QAing, and just making sure that those products get created to the specs that are necessary. We have, if it's low tide acquisition or high, you want a certain sun angle, right? There's a place where, you might want to go the custom collect route. We're happy to talk about what's out there in the market to buy versus how you might go about getting your own collection going.
Yeah, and lastly, we've even worked with some towns who are doing their own internal collection with drone imagery. And that's another avenue where we've been able to tile it and host it through Giza. Pretty cutting edge stuff.
Great. Thanks, Aaron. And thank you, David. And so we have another question. We publicly share our image services now through a data portal. With Giza, would you still be able to do that even with the user-specific settings?
Sure. So I'm assuming through data portal, kind of like the data clearinghouse kind of model for states, every state is going to have its own process around sharing the imagery and distributing like a WTMS link when it comes to the level of access that you want. So, the nice thing about the user control is you can dial up or down the access that a particular user or link associated with it has. This also lets you give expiring links. So say you only want to give access for 6 months, it would shut off after that time. They'd need to come back to you for more. David, would you have anything more to add about that kind of provisioning or, kind of public provisioning?
Yeah, no, definitely. So some of the thoughts that come to mind, if you're currently delivering through your portal, as Aaron mentioned, a WMTS link, and you could use Giza, create a public kind of user, give it access to whatever that data may be, and then publish that endpoint, I assume, on this portal. And then Giza would track all of that usership, so you could have some of that interesting reporting. Another thing that we didn't mention is there's a Google, if you had, let's say, imagery that was sensitive for whatever reason in some area, the Giza appliance has an ability to clip certain imagery kind of to a given geographic area. So there's an ability to kind of tailor how much is exposed and for how long. So in short, I think yes, Giza could very likely be integrated in your solution, but we'd love to talk more specifics and just understand that particular technology.
Great.
Excellent. And so the next question is more of a comment than a question. If you do need new aerials, I'll address that. We do project management and quality control of imagery acquisition programs all over the country. We can absolutely help with RFP development or any other kind of aspects of your aerial imagery program. So just to kind of address that, we need new aerials comment. Another question that has come in, can an end user perform image geoprocessing, ergo building feature extraction from your GIS desktop software using the Giza image service layers?
Sure. I'll let Dave take the first stab at that one, just because he's done a lot in that area.
Yeah, so it kind of, from a feature extraction perspective, there's, expert system approaches, and then there's ML approaches, both of which rely upon the raw data. You want those raw TIFFs available. They need to be processed to kind of facilitate that workflow as it is currently done in, yeah. So to answer your question, that I haven't seen WMTS links or people use that vehicle to feed an ML or a feature extraction pipeline. That being said, conceptually, it's possible to do that. The seam lines of the tiles and what that could do to your analysis when it's looking for features that overlap. Again, there's some edge cases that might make that challenging to get like seamless vector features extracted when you have those overlaps, because you'd be looking at individual tiles. So in short, we haven't supported a customer to create a WMTS kind of a WMTS pipe into their ML process. However, all of the data stored in cloud stores, like a bucket, right? You run routines against buckets of imagery. That's a very common way. And we have seen data pipelines that leverage that raw storage of JP2s or GeoTIFFs.
Excellent, thank you, David. And if that doesn't answer the question fully, of course, we can. You can always reach out. You do have my email. I know who asked that question. Next, can Giza serve LiDAR?
So I'll take the first stab at that, and this is actually something we've been hearing a lot, is LiDAR is becoming almost equally important as imagery for a lot of applications. LiDAR comes in a lot of shapes and forms, and in its purest form, we're talking about a point cloud, a collection of dots, each with a varying height, and it's really not raster data at all. And as far as we've seen, there are very few, if any, capabilities to really stream LiDAR in a real-time environment, just because of the density of data that we're talking about here, and also just how it can be really visualized well. That said, oftentimes the result of LiDAR, we can process it into a DEM or a surface elevation model. And because these are stored in a raster format, in theory, that could be served alongside imagery as well, thematically, for example, with different pixel values representing a different height, or Z as it's often referred to. Being able to click and get that exact value out may be a limitation of what software you're using. And it's not something we've heavily worked with yet, but we see it being, potentially a need down the road. So we are keeping our eyes on that use case. Anything else to add there, David?
Actually, Aaron, it's kind of a good timing for that question, because I've actually been doing research into how do you bring massive LiDAR point clouds to the web, to a browser? How do you serve it? And what are the storage formats available? I would be happy to take that, have a longer conversation. In short, we are seeing open kind of standard that leverages an octree. Basically, it's like a tile pyramid for point clouds, and that type of data format can render up to 10. I've seen, technically you can render as many points as you want in your client, but you're ultimately going to run into some performance challenges if you overwhelm your web client. But we are seeing tools out there that can start to do this. Giza doesn't do this currently, but we're currently thinking about how the cloud infrastructure, the tools we're familiar with using for Giza, to create a similar storage and delivery mechanism to end users. But as Aaron said, LiDAR comes in many shapes and forms: terrestrial, aerial, bathymetric, mobile. There's a fewer there are standards, but there's more varietals to handle, and so that creates its own challenges. But in short, happy to talk about your needs and what we're doing currently to kind of solve that problem.
Yeah, sounds like a good topic for a whole nother webinar down the road. So
definitely,
you'll be hearing more on this one for sure.
Excellent. Well, that does wrap up the rest of our questions. So I want to thank everybody once again for joining us for the Introducing Giza Advanced Performance and Analytics for Streaming webinar. Is there anything else before we wrap up today, that last comments we can get through? All right. Well, on behalf of our speakers, I want to thank everybody for joining us, and thank you from Applied Geographics or AppGeo. We hope you have a great rest of your week. And the contact information, if you do want to reach out directly to our speakers, is now on your screen. Once again, we will be sending the recording out to all who attended today and all who registered who may not have attended. Thank you.
Thanks, everybody.
Have a good afternoon.